Hello guys, welcome back to Piping Engineers. So friends, welcome back to our today's video. In today's video, we will be discussing about the top 20 technical piping interview questions that can be asked in a supervisor's interview question. So today's video will be very interesting friends. Stay tuned with us for today's video. I hope you will definitely learn something out of it. So let's begin our today's video. So first thing, friends, when it comes to the interviews, so people are mostly ask you the questions of piping and instrumentation diagrams. So they ask you what is your experience with piping and instrumentation diagrams, what piping and instrumentation diagrams do, and what is the role of those piping instrumentation diagrams. So friends, these documents they are essential for understanding the layout and specifications of piping system. So I guess you can accurately identify pipe routes, fittings, walls, and instrumentation, which allows you to guide the installation and inspection process effectively. So friends, your familiarity with these diagrams ensures that you have a complete knowledge of how the process works. You have the complete knowledge of what are the pipes involved into the system, what are the walls involved in the system, why those walls or those instruments which are present in piping and instrumentation diagram shown into the system. So this is a very effective and important document, and the first document which is prepared when we start the project. So you should be aware of the piping and instrumentation diagram. For this purpose we already have a detailed video on piping and instrumentation diagram which we will put on the I section. Please go and watch that video. It is very helpful and you will definitely learn to know how we read piping and instrumentation diagram and or how we make piping and instrumentation diagram. So moving on to the next slide friends. So the next question is, how do you ensure material compliance? So friends, there are different types of piping materials that are used in projects. So to ensure piping materials, if they meet the project specifications, what you have to do? You have to begin thoroughly by reviewing the project documentation. So why project documentation? Because project documentation already ensures what are the material requisitions and specifications that are required for this project. After that, verification of material certificates. Again, every material that is supplied, it is supplied with MTC means material test certificates. And again, the material test certificates, you have to verify it against the standard and verify that the material specifies to the conformed grade. After that, inspection and testing is basically you can your QA QC document department, they necessarily perform tests such as PMI, which is your positive material identification, and hardness testing. So this process, what happens, this process ensures that only compliant materials are used, which are vital friends for safety, performance, and integrity, because it's our plant or our system, we cannot use anything like it. Okay, so moving on to the next slide. What are the types of pipes and fittings used? So pipes and fittings, as you know, they are essential components in any piping system. We already have many videos on our channel. You can go to the playing list and see the videos. So piping and fittings are very essential components of piping system. They serve as various functions, such as, if you want to change the direction, we again need a fitting, branching, or connecting different pipe sizes. So common types of pipe fittings are, elbows, which change the direction of flows, T's, which allow for branching, you know it very well. Reducers, again, when we connect different type diameters of pipe. Flanges, again, it's a method of assembling the pipe when we don't want to use the welding process, or when we want to make a temporary sort of connection, because maybe we want to do the further inspection or cleaning at a future date, so we go for flanges. Again, it's a method of assembling and disassembling, you know it very well. Piping system and couplings, again, couplings, what they do, they connect two pipes together. So each fitting is selected based on system's pressure, temperature, and fluid characteristics. Understanding their application ensures the pipe proper installation and system integrity. So all these types of fittings should a person be aware of. And if a person asks you in the interview, maybe regarding your classes of walls and fittings, you should be aware of that as well, because that is the important criteria on how those fittings are selected for a particular piping system. Moving on to the next slide. So what is concentric and eccentric reducers? I hope you would have definitely heard both of these things quite often. So concentric reducer is a symmetrical shape. It has symmetrical shape in which both ends are aligned with the same center line. So the diameters are different, but the center line is same. So it is ideal for vertical piping systems when we want to connect two pipes vertically. So it is used, and where the fluid flow is consistent. In contrast, an eccentric reducer has an offset center line. So the center line of one end is not matching with the center line of the other. So which is an offset, which is used to connect a horizontal piping to prevent air accumulation at the top of the pipe. So in when we connect the piping system in your pipe racks, we when the pipes are running horizontally, we go for your eccentric pipe reducers. So this is the distinction in a critical piping system where we want to maintain a continuous pipe flow, okay, without air pockets is essential, such as the one of the most important systems where eccentric reducers are used is in the pump suction lines, because we don't want air pockets to be trapped in the pumps suction line, because if those air pockets are trapped, maybe they will damage our impeller. So proper selection is important, and proper selection ensures efficient fluid dynamics, and it prevents operational issues. So you should be aware when to use concentric reducers or when to use eccentric reducers. They have different roles to play in the piping system. Moving on to the next one. So hydro testing procedures. So friends, hydro testing is again a very critical quality assurance process which is used to verify the integrity and strength of piping system. So if we hydro means water, first of all, huh? When we test the piping system with water, a pressurized water system, so it is called hydro testing. Hydro testing. We have again a detailed video on hydro testing. The link will be on I button. Please go through it. Definitely you will have you can learn more. So it involves, what happens, what is the process of hydro testing? It involves filling the system with water and pressurizing it to a specified level. Basically, it is pressurized to the design pressure, or maybe 1.5 times of the design pressure, and monitoring it for leaks, and pressure drops. Before testing, you should ensure that all joints and connections are properly secured. If that's not the case, then it can lead to hazard, because or either the water may leak, or the system will not be able to give you the testing results which you wanted to get. So, and the system is properly secured, and the system is vented to remove air pockets. So there we provide vents at sufficient locations so that there are no air pockets. And in this system, what we use, how do we use calibrated pressure gauges and follow test procedure as outlined in SME codes. So SME 31.3 gives you the detailed specification on how to perform this test. You should be aware of it. Any leaks or deformations are documented and rectified before proceeding to commissioning. So this is the when we say the construction is ready and the systems are ready for commissioning, so the end step or the first step towards commissioning is the hydro testing. So we should be aware of it. Okay, I guess you would have learned how we do the hydro testing and how it is important for the system. Moving on to the next one, guys. So what is the purpose of pipe support? So again, pipe supports are like the legs of a body. So pipe supports are designed to maintain the alignment and stability of network. So if you don't give the pipe supports at designated locations, your pipe will sag, and not only it will sag, it will move, or it will have vibrations. So to reduce the sagging, to reduce vibrations, or to accommodate thermal expansion and contraction, proper support placement is very important. You should be aware of it. So why proper support placement is important? Because it minimizes stress on joints and connected equipment. So if you don't provide a pipe support at a designated location, your pipe will sag, and then it will have a impact at your joints, and it may be possible in long run your joint may get leaked and a disaster can happen. So that's why it is very important to provide the correct supporting at pipes. So thereby to extend the lifespan of the system, we provide the supports. Okay. So how do you ensure that supports are installed accordingly? So we have design specifications, and based on those design specifications, and it varies upon again pipe size to pipe size, what type of support and how much distance will be there between the two supports. and then they are inspected regularly for wear displacement. It's not the case that you provide a support and after that you don't even see it for 20 years. It's not the case. Maybe in routine maintenance you will check whether the supports are capable of taking the pipe load, whether there is no wear tear, whether there is any wear tear or not. So this is a proactive approach, guys, and it helps in maintaining system integrity and operational safety. So I hope you would have understood the purpose of pipe support systems as well. Moving on to the next one, how do we manage welding activities? Again, welding is like you cannot do anything without welding. So if you want to join something, and even if you want to cut something, we use welding. So managing welding activities involves ensuring all welding operations complied with welding procedure specifications. That is WPS. So the WPS is your mother document, and second is procedure qualification records. That is PQR. So people who are in welding field would have heard about these two documents often. So what do you do when you are on site? So first of all, you have to ensure that the welders are certified for specific process and the type of welding that is required from them, 1G, 2G, 3G. They have that certification, and they know the material and processes on which the welding has to be done. And after that, you should also ensure the environmental conditions suitable for welding and coordinate with the quality teams for inspection and NDT, because sometimes we have to do NDT as well, or visual inspections as well. So if you have done oversight, or maybe if you have not done the work properly, so then there can be a problem with quality of the welds. Your rework would increase, and your safety and compliance can be an issue at a later stage. So welding, if you are getting the welding done at your site, you should be on your toes, and you should properly check each and every document and properly check the quality of the welds that the welder is making, and proper quality testing should be done whenever required. Moving on to the next one, guys. So what are the common welding defects? Again, when you are working on site, you should be aware of not only of the procedure, you should also be aware of the common welding defects. So common welding defects include porosity, cracks, undercut, lack of fusion, and incomplete penetration. So these are few of the important defects that we see quite often on site. So these defects can compromise the strength and integrity of the weld. Okay. So what do you check? You ensure that all welds are inspected visually. So visual inspection is the first inspection, and after that NDT processes such as radiography or ultrasonic testing should be done. So interviewer is very intelligent these days. They try to ask you each and everything. Maybe if you are working in different fields, so you should be aware that radiography, ultrasonic testing, how these tests are done. Basic knowledge. Again, if you are not the expert, but basic knowledge you should definitely ask. And what happens if defects are found? So if defects are found, what is your next role? You coordinate them with the welding team, welding supervisor, to perform repairs and re-inspections. Maintaining a robust inspection process is essential. Again, if your inspection process is not good enough, then you will have problem. Definitely you will have problem. Maybe in terms of leakage, maybe in terms of leakage at a later stage, or even safety hazard can be a problem if the pipes are charged and the welding is not done properly. So this is an important role of a supervisor which he has to done, and to check the welding properly on the site. Moving on to the next one, guys. So what is the difference between pipe and tube? So again, you all are very intelligent on this part. I guess this we have discussed many times. But pipes and tubes, they differ primarily in how their sizes are measured. Okay. So pipes are measured with their nominal diameter and wall-to-wall thickness, while the tubes are wall thickness, sorry, and tubes, and they are typically used for transporting fluids. While tubes, on the other hand, they are measured with their exact outer diameter and wall thickness, and are often used in structural applications. So that is the basic difference. But understanding this distinction is important, for selecting the appropriate component for your system and given application to ensure the compatibility. So you have to know how to differentiate between them. When maybe you have to buy something, you have to get something from your store, so you should know that proper nomenclature what you are asking. So that is the basic difference between pipe and your tube. Okay, moving on to the next slide, guys. Today this will be the last slide for our today's video. So what are the functions and types of flanges? Again, we have all these videos we have made on detail topic wise. You can definitely reach out to our channel for these videos. So flanges, as I mentioned you previously, they are used to connect the pipes. When we don't want to do the welding, you can go for flanges. And let me tell you, most things like walls, pumps and other equipments, they all have flanges at their ends, and we connect them with flanges only. So flanges, they have this class pressure rating which we call class 150, 300. Based on those classes we select the flange. Okay, so why we you go flanges? They allow for assembly and disassembly easily. Okay, which is essential for maintenance and inspection. This is the important point, and people generally ask this in interview. So common types of flanges, they involve weld neck, slip-on, socket weld, lap joint, threaded and blind flanges. Again, all these flanges, we have a video I told you earlier as well. All these flanges, they are selected based on the temperature, pressure, or on which for which service we are using. Okay, let's say for an example, if you are providing flange for a steam line, so it will be your weld neck flange only. Okay, because steam lines have high pressure, high temperature, so we will go for weld neck only. So this is how the flanges are selected. So each type, again I told you, they have specific problems, specific uses. Proper selection is very important, guys. If you don't select the flange properly, it will be a definitely hazard at a later date, maybe because of leakage, maybe because of reliable connections. So that's why you have to make sure that you select the correct flanges. I hope in today's video definitely would have learned something. Please feel free to comment if you want to other videos on this topic as well. For other videos, please like, follow and subscribe to our channel.